Hi. Hello. Just checking. Okay, everything's good. Perfect. So hi, welcome to this talk. I have a very important question. Who is hungry here? A few people. Okay, I hope you're hungry for code because that's what we're gonna eat today. So let's get started. So who's heard of Square before? And who's heard of who's heard of Square libraries? Yeah. And then the next question is obviously who's heard of Jake Wharton? Everybody. Yeah. So he's one of our great engineer, and he does a lot of open source. Today I want to talk about a few of our, actually three of our open source libraries. But I'm not going to present them in the usual sense. I rather want to explain why we're doing this thing and the underlying concepts. The idea is that I don't really care if you use the libraries or not, but what's interesting is thinking about why we're doing these things, and maybe you can apply the same principles in your app. So our mission at Square is to make commerce easy. And that's like a general mission. So the main application for that is a point of sale application, a Square Register, which started as a small Android app, as you can see, and a hardware reader to read the magnetic stripe on a credit card. So you would just swipe your card, and the app would get the data, and you could take a payment. This app is core to our merchants, and it needs to work great. One of the things that we started working on a few years ago is making a tablet version. So we need an app that has, the same elements but organized differently, and we need to have a very complex app. We have several feature teams collaborating on that app, and basically, at the same time, you have, a small team of engineers contributing to different parts of the app, and so you really want to find a way to organize your code so that you can make that easy and everybody can work on a different part of the code without working on each other's footstep. And also, you want to avoid, too many crashes, and you basically want to make it simple. So how did we do that? Initially, a long time ago, our Android app had several activities because we were navigating through a flow of activities. So you're taking a payment, you're on the first page, and then you go to the signature page, then to the tipping page where you add a tip, then to the last page. And so you had like a flow of different activities for many, many different features in the app. And that was great, but activities don't leave you a lot of control. And one of the problems became that we needed tablet UIs. And at that time, fragments came out to support that problem. So who's using fragments here? Pretty much everybody. It's cool, interesting. So this is what fragments are. Yeah, so it's nice, it's great, right? It's the idea that you can compose your UI, your activity with several fragments, and you can reuse them in any place. It's just gonna work, it's gonna be great. That's kind of the reality. So you have like the life cycle of fragments here. That's, fragments, right? And that's for an example from the fragment manager implementation. I don't know if you've been looking at that code before, but when you have a bug, you go in there and you're like, okay, I need to understand what's going on. And then you look at this and then you're like, I don't know, I'm quitting, I don't do anything anymore. So yeah, and we ended up having a lot of bugs in our code, a lot of crashes. The lifecycle is complex. It took us a lot of time to develop. And one of the key problems with fragments is just the core design principle is that you have components that are both responsible for creating and managing views and organizing and setting all the UI parts, and also taking care of the business logic. And when you think about that, what's really interesting when you write an app is to write unit tests. Well, I'm going to ask a question here. Who writes unit tests? For real? I mean, yeah, not too many people. But the thing with unit tests is when you start testing the UI, it becomes very difficult because every time you change something, your test is going to break. Testing the business logic is much more valuable and also is less likely to break. So we needed to, oops, I'm losing the comment, okay. We needed to like split apart the business logic from the view, and fragments don't allow you to do that because everything is kind of in the same place. So that's where fragment leave us. And I wrote an article on our blog post. You can look up corner and then you can find that probably, explaining why fragments are bad. And I'm not going to go into much more details here. But we decided to get rid of fragments. So what did we learn from fragments? There are a few very interesting lessons, and it's important to just take a step back and think about that. The first is the single activity interface. You don't need multiple activities, you can do everything with one activity. That's kind of the lesson you get from fragments, like the idea that you compose your UI with different parts. You don't need to rely on the activity backstack. So you know, in Android you have a stack of activities, and as you start new activities and then press back, it finishes the activity and goes to the previous. Well, you actually have access to the back button, and you can totally re-implement that mechanism. And then DIY, do it yourself. The idea that with activities and views and layout inflators, that's like the three main components that were here from Android 1, and they are great, and you can do everything from that. We built fragments. I mean, fragments were built on top of the existing framework, and fragments never needed to be into the Android framework. They could have been in the support library, and that worked really well. Well, not so well, but that's the idea, that so you can build something totally different, but having the similar, to do something similar as to what fragments are doing. So let's talk about the backstack. So we have an activity. Yeah, I'm sorry, it's a bad name. Anyway, I wanted to talk a little bit about the backstack and what's the notion of a backstack. So it's the idea that you're navigating through screens, and then well, it's very simple to implement when you look at that. So if I want to go to a screen, well, all I need is like a queue of screens, and then I'm going to put stuff in that queue and say, hey, now show this screen. And when I press back, I just need to look if the stack is empty. If it's not empty, I just remove the last one and then show it. And otherwise, if the backstack is empty, I guess it's time to leave and finish the activity. So really implementing that is not so hard. And then show screen, I'm not showing the details here, but the idea is I create a new view and I attach it to a container, and then I animate that view in to make a nice and smooth transition. So we built Flow for that. Flow is basically the code you just saw previously, but wrapped with a little nice things, but it's very simple. It's the idea that you have a central object, which is Flow. It's the navigation controller. It holds the queue of screens that you just saw, so it's called the backstack. And then you just tell to Flow, hey, I want you to go there, I want you to go here, or I want you to go back. And then it handles the maintaining the backstack and understanding where you should go. And then a screen is very much like a URL. You have to think like, as in a browser, every URL is like a different screen. And every URL can have a bunch of parameters, and also will eventually render some view. So that's kind of the same idea. Our screen potentially has parameters, like I want you to display the screen to edit this particular item, and then it has a layout that it's going to display. So let's take an example. So in Square Register, you can edit a discount. It's a kind of very simple screen. So when you click on New Discounts, we just get the Flow object and we say, Flow, go to the discount screen, right? So that's not terrible. That's like, I think, easy to understand. And then what is the discount screen? It's just a simple class. It implements parseable, or you could do other type of serialization, but the idea is you want to be able to save that screen in the backstack, and then you want to be able to serialize the backstack when the activity is saved, so that if you come back later, 2 days later or something, and the process has been killed, it's going to be restored, and you're going to have the exact same backstack. So it's going to work like magic. And then you can see the parameters here. So basically just some data, like here the ID of the item to the discount to edit. It's very simple. Then we have here. Basically, we get the backstack. It's actually hard to show and look at the same time. But the top part is, okay, I need to save the backstack. That's very easy. I just make a parcelable out of that backstack and put it in a bundle. And same idea, when I create Flow, I need to give it a restored backstack from the bundle, and then Flow doesn't even handle the view switching itself. It just has it handles manipulating the backstack, and then delegates everything to a listener. And in the listener, that's where you're supposed to write the code that inflates the view and attach it to the container. Cool. So I hope that was not too hard, because we're gonna get started on the very hard parts. Flow is simple, and now let's talk about more fun stuff. So who knows about dependency injection here? Cool, that's a lot of people. So dependency injections, it comes from a very simple principle, which is the single responsibility principle initially. It's the idea that you're gonna write small components that are gonna do just one thing, and they're gonna do it well. So image controller, the image downloader, the image cache, and then you can compose all these things to have your higher level component being able to do greater things. So instead of writing all the code in one giant method with 1,000 lines, you have a small thing and you just compose them together. Now, the image controller here, it needs an image cache and an image downloader. And the image downloader needs a HTTP client, and the image cache needs a file reader. So you have all that code in here to create it. There's a problem with that. The problem is everything is in one place. And that's where we introduce dependency injection, where the image controller just gets the thing it needs and doesn't have to care about how to construct them. And then in some other place, we write the code to construct everything. What's great with that is it makes it super easy to test image controller, because you can pass it a fake image downloader and a fake image cache, and you don't have to create all of the real objects when you test your things. Also, it's make it easy to switch configuration. For example, in dev, you might want to switch the HTTP client to another endpoint, like your development endpoint. And finally, it's also very interesting because it provides the ability to create singletons and share instances across components without having to statically reference them. So you could have an image downloader that's shared by different controllers. So yeah, I like this dog. It's very exciting. This code at the top, it's kind of boring. Like when you think about it, it's got new thing, la 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 la, and you can make mistakes if you get the ordering wrong. So let's get rid of that. So we basically want to say, I want an image controller, just do the magic, do the vodka magic or something. Do the boring things, please. And so that's what Dagger is about. Dagger is about just replacing the boring boilerplate part with automated magic. So it works at compile time. It's going to analyze your code at compile time and tell you if there's any error, and then it's going to generate some code. And all it needs is basically add inject annotations, a few other ones, but mainly add inject. So let's come back to the code. We now have the image cache, and all we added is basically this add inject and this add singleton interface. I'll come back to that in a minute. And then same thing for image controller. Everything needs to have an add inject. Basically, Dagger needs to know about that object to be able to inject it. And Dagger doesn't want to deal with zero arc constructors, because that can lead to mistakes. That's what Google Juice allows you to do. So you can inject, if you inject a string, it's going to be just fine. It's going to be like, okay, I'm going to create an empty string for you. So it's very easy to do mistake if you allow injection of non-annotated constructors. Now, I don't know if you know, but there are two versions of Dagger, Dagger 1 and Dagger 2, and it might be a little bit confusing because Dagger 1 was created by Square. Dagger 2 was was developed by Google. We talked a lot together, Square and Google, and really they wanted to take that further, and I think they've done great things with Dagger 2. So let's talk a little bit about Dagger 1. So in Dagger 1, you have this object called a module, and you define what's called an inject or an entry point. Here, the image controller. It's the object that is not created or that is kind of at the edge of the object graph. It's the one that's accessed from the outside. So here, it's the object that I want. I want the image controller. That's the only thing I care about. And all of the dependencies are going to be created automatically by Dagger. And then I create an object graph from that module. So the module has all the information Dagger needs. And then when I said, hey, Dagger, give me a object graph, vodka magic, give me an image controller, it just gives me that. It just works. Dagger 2 is slightly different. So you still have the module as before. But now you have a new thing that is a component. And the component basically says, hey, the module is this module, and defines what it can provide to the world. It's an interface. and then Dagger 2 generates an implementation of that interface. So the big difference is that the object graph doesn't exist anymore, and Dagger 2 will generate a single object graph class for every component interface. So an object graph is now called a component, and it's generated. So the class that you see here, Dagger vodka components, is what's generated, and then it's the same thing. It's like give me the components, and then give me the objects. The huge difference is that Dagger 1 was more efficient than Juice, doing a lot of stuff at compile time, but still had a little bit of reflection. Dagger 2 has no reflection at all. Everything is generated. The code is super readable. The stack traces are really nice. So I really love Dagger 2. It takes a little bit of getting used to. Also, I really like the concept of component because it make it very clear what you're exposing to the world and what you need, whereas modules are kind of composed together, and it's not really clear how things are working together. Okay, so we've seen dependency injection, and we're halfway through the talk. Let's get even more code. So let's talk about best practices. One of the things we've learned is that custom views are great, and we use that a lot. In fact, you used to write all that view code, like find view by ID. So you used to do the find view and the settings and all that in activity, and then with fragments, you're starting doing that in fragments. Well, what we do is we do that in custom views. So we have like some sort of container that's going to take care of finding its children and controlling them. And it's like a fragment, except it's just a normal view, and you don't need fragments for that. So that's really nice. But like I said, we don't want to test the view logic. We want to test the business logic. So we extract the code into presenters. You could call them controllers or whatever you want. But it's the thing that has the business logic, and we want to test that. So we extract it, and then the view talks to the presenter, and the presenter talks to the view. And we only test the presenters. So let's come back to our example here of the discount. We have a discount view, very simple. And we're using Dagger now. So we're getting a presenter injected by Dagger. And then when you press back, we say, hey, presenter, it's time to save the discount. Okay? So in the presenter, I'm just going to show also we have like the presenter knows about the view and injects all of its dependencies. Well, it needs a whole lot of things, and maybe we could split that code because that's a lot of things in the constructor. This is actual real code that's shipping in register. So the presenter is created by Dagger. And then when I want to write a test, in my unit test, I can mock all the dependencies. I can create a presenter without even using Dagger. I just use the normal constructor and pass everything I need. And then I can write a test here. Like, oh, so when I save the discounts, I want to make sure that the view shows the warning. The presenter tells the view to show the warning, the name is empty. So this is a very clear test, and also we want to test that we're not saving anything. We don't have any pending saving task. When I read that test, to me it's very clear what we're trying to do, and there's no like crazy view logic. Now there's also the notion of scope singletons in here that I want to present. So a singleton is basically an object that can get re-injected several times, the same instance. So it's the idea that you're going to keep an instance, keep it around, and reuse it. And when you think about Android, you all know, configuration changes, rotations. It's terrible, and I mean, everybody has crashes due to that. Like, oh, you rotated, you press the button, you rotate it back, and now it's on the wrong instance of the activity. Everything is sad. So to avoid that, you want to write your business logic in a singleton that's going to survive activity changes, activity rotations. The views are going to get destroyed and recreated, but the idea is that the views and the singleton are tied together, and when you rotate the screen, the views are deleted, the singleton presenter stays here, the new views go in, and they reattach to the presenter, and then it continues its logic. So you don't have to reload everything, and you don't have to care about rotation in your business logic. And to achieve that, though, we can't just put singletons, because if I talk to you about an object graph, and the object graph is the thing that holds all the singletons, but if you keep all your instances in there, then as you go through the app, nothing gets garbage collected, so you have like a ton of objects staying in memory, so that's bad. So what you want is, as I go to the screen, I'm going to create the singletons I need. If I rotate, they're still here. But when I leave the screen, I want the singletons to be garbage collected. And the way you do that is by creating what's called a plus graph or a subgraph. It's it's like a graph. Basically, you have you have graph inheriting the parent graph, and so you have, for example, an application graph that's going to stay for the whole life of the application, then an activities graph that's only here for the life of the activity, and it has access to some objects in the application graph, etc. And we have like screen graphs, and so that's the code we use to create a subgraph. So basically, I have the root graph, and I'm going to create a new subgraph with this module, these extra definitions, and then I can do stuff with that graph. So that's how we handle that. So every single screen has a dedicated object graph that contains all the singletons for that. What's great about that is it's making everything so simple. However, we need a little bit of extra code to help us with two things. One is managing these scoped object graphs, creating them, holding them in memory, and deleting them when the screens are leaving. And another one is adding lifecycle callbacks to the presenters. We don't want to be destroyed when the activity rotates. However, we want to be able to save and restore states, because we know that the process might die at some point, and we need to be able to save when the activity on save instance state method is called. So Mortar is the library that provides just that, and that's very simple. And like I said, you don't need to use Mortar, but I think it's very interesting to start using custom views and presenters and extracting business logic and writing unit tests against that. So in Mortar, you basically have a view as before, and you inject that view. But the big difference here is I'm going to show you the injection code here. So this is when we actually create the presenter instance and set it here. So at that point, the presenter instance is set. What's going on here? A whole lot of magic. So we have a context object, and from the context object, we extract the current scope. And the scope is the thing that holds the reference to the object graph of that screen, right? And then we get that object graph, and then we say, okay, object graph, can you inject the fields in this instance? And I'm going to show you how we do that in a second. And then the next interesting bit is in unfinished inflate or unattached window, depending on what we're doing. We could do it in a different place. We say, hey, presenter, now you have a view. The view is ready to show, and that's usually when the presenter will load its data and display things on the view. When we're done, we say, hey, presenter, I'm not here anymore. Don't try to use me or whatever. That way, the view can get, the presenter will stay in memory, but the view doesn't stay in memory. The presenter forgets the instance of the view. That means the view can get garbage collected, and the bitmaps associated to that view are going to get garbage collected. So it's very memory efficient. Yeah, so let's look a little bit into this mortar.inject thing. How do you, so, if you look at this, all I'm doing is giving it the context. Why a context? What's the point of a context? What can you do from that? The thing with the context is something we realized, it's quite magic. You don't have, contexts aren't just activities and application. You can make your own context. And you can hide stuff into context. So that's what we do. Because when you're in a view, and the view is created by a layout inflator, right? When you do set content view, the activity will get the layout inflator from the current context, and then inflate the XML files, the layout, and create all the view objects. Well, it creates that by reflection. And it doesn't have any way, when you're in the view code, you don't have any hook to actually access the object graph. The only object you have is the context. But this context can be a fake context, which is a context wrapper. So we create our own context wrapper. It might be a little bit weird, but it's kind of interesting. And we kind of abuse that actually, but it's so nice. So you basically create a context wrapper, and you give it the object you want it to hold, which here is the scope, which is just an object holding an object graph. So this context wrapper has a scope, okay? And it has a parent context. So it might be the activity, or it might be another fake context like this one. So it delegates all of its code to the actual real context. So it works like a normal context. But then the interesting bit is get system service. So we abuse get system service so that if the name is something we know of, here it would be like Mortar scope something. we're like, oh, that's the thing I know. I'm going to return my objects. Otherwise, we just return, the normal one, so you can get access to the normal system services. And then we also have this little bit of magic here, which is if you're asking for the layout inflator, because I don't know if you've noticed, but there are like 3 or 4 ways to get a layout inflator in Android. You can do layout inflator.from context. You can do get system service layout inflator, and you can do view.get layout inflator. Maybe, I'm not sure. But anyway, in the end, it's always going through the context and asking the context, give me the layout inflator system service. In here, what we do is, oh, you want the layout inflator? Actually, I'm going to create a fake version of it. Another one, well, it's a real layout inflator, but it has a different context. It has myself as a context, so that when you try to create subviews and like a whole view hierarchy, everything in that view hierarchy will be created with a context based with this context, because it will be using this layout inflator. So that's kind of the interesting, really nice stuff. So you should look into that. It's really cool. Anyway, that was the idea. So then now we have a presenter with a lifecycle, and the presenter is it's a singleton as usual. And I'm gonna just that's not what I wanted. We're almost finished. You saw that? That's cool. So then you can get some food and actually eat and not eat code. So as you can see here, so on into scope is a callback. So like I said, Mortar adds lifecycle callbacks. On into scope is a callback that tells you the screen is being showed. Now it's time to prepare the data you want to load if you need to. When you rotate, it's not going to get called anymore, because the singleton lives there for the whole life of the scope. When the view gets in, onload gets called. And that's when we do, okay, so is it a new discount? Yes, then I don't have to load anything, and I just tell the view, hey, show, empty fields and stuff like that. Oh, no, do I have a model already loaded? Well, then let's just display the model. Otherwise, well, let's show that I'm loading the model, and at some point this will finish triggering, it's in background right now, and it will update the view. That way, it's really easy to write code that way. I mean, we've been banging UIs after UIs, and we're about, let's say, 20 engineers working on the register Android, and we'll have I don't know, five teams maybe. I'm making up numbers right now, but basically everybody's working on different parts, and so far it's been pretty good. So that's about it. So I hope you like this. I know Mortar and Flow don't. It can be intimidating. There's not a lot of documentation, and we're working on that. And same thing for Dagger is a bit more documented. What's interesting here is not so much using these libraries, although I would advise you to use them, but you don't have to. But thinking about what you can do with custom views. Because if you've been doing Android for a while, you know activities very well, you know views very well, you know how they work. But you look at fragments and you have no idea, what the hell is going on? What is this thing? When you've done that, right? You start a fragment transaction, and it's well, it's gonna get executed in the future. We don't know when. If there's a rotation, maybe not. And then your fragment is staying. It's not showing, but it's staying in there in memory. And you have phantom, ghost fragments. I mean, I've had, and then when you start to have fragments into fragments into fragments, things go crazy. Especially if you want animations, it just doesn't work. However, views are simple. You have an activity. Android is made of windows, right? It's just displaying a bunch of windows. Every window has an OpenGL surface, right? And so every activity has one window, and that's about it. And so when a view, I'm just taking a step back and trying to explain. In Android, you have every activity has one window which has access to an OpenGL surface, and then every window just has one view, which is the root of your view hierarchy. And that's very simple. Every 16 milliseconds, the clock ticks, and it's okay, every window now is going to try to update the OpenGL surface, and it's going to call into the root view and tell it, it's time to measure, to layout, or it's time to draw yourself. And then the root view is just going to say, hey, children, it's time to measure, layout, and draw yourself. And it's just views all the way down. With that in mind, it's super simple to think about views and how they work, and activities and about how they work. And yeah, you basically don't need any fragment, and you can do everything in custom views, and then you can extract your business logic in presenters or whatever you want to name them, and you can write unit tests. So I hope you will write unit tests from now on. That's about it. And if there's any question.
Hi, first, thanks for open sourcing so many libraries. They save a lot of time for my friends. Okay, that's better. I have three questions, if I may. The first one was in the Dagger 2 slide. There was a module annotation, and it was listed the list of the class that you will inject into. I thought that they were supposed to be gone in Dagger 2, and do you still have to list all of them?
I think so. Let me. Where was I? No, before. So on that screen. Nope, they're not gone as far as I know. No, because you need, so basically, now you're giving me, that's a good question. Maybe they're gone. They're gone? I'm sorry, copy-pasted code, okay. So, that's right. There are things that are, so we're still, so actually in our register app, we have Dagger 1 and Dagger 2 working together. Because it's a big app, so migrating is not easy, and so we basically, it's kind of crazy, but we have bindings. Basically, everything is in Dagger 1, and then some of the bindings are actually provided by Dagger 2 generated components. And I did that, so my mistake, yes. A lot of the things in Dagger 1 are actually going away, and so that's actually very logical what you're saying, because here, the whole point of the inject is to define what's the entry point, and that's what the component interface is actually for. So that's a very good point. Thank you.
The second question, do Mortar provides a way to display a dialog or some overlapping views?
Yes and no. So does Mortar provide a way to display dialogues? We actually have in the samples, we show a way to do that. But taking a step back, we realized that it's not really Mortar's job, and it's more like, it's actually more flow, because if you think about it, what you want is to show something, and then flow, or like your component responsible for showing that, will say, oh, this is actually a dialogue, it's time to show a dialogue. On dialogues, a quick word. Dialogues are interesting. Like when I started using Android, I hated them because they, especially with the activity, they are managed. So you're like showing the dialogue, and then you rotate, and then you don't know if it's showing again or not. And you're like, oh, is it showing? And if you try to hide it, it's going to crash, saying, no, it's hidden already. And so you get all of these crazy situations. But if you start managing the dialogues by yourself, and then you don't really use the other dialogue stuff and all of the provided things, it's actually, when you look at what a dialogue is, it's just a simple, I talked about windows. A dialog is just a simple wrapper around a window that provides a few utilities for manipulating windows. So with that in mind, you can create, like I was showing you, took a dog, but that's not what I wanted to show. Yeah, this here. So right now it's not, because we did it a different way. So in the current implementation, there's a frame layout as the root, and then we show this thing, as a view on top. But we could use dialogues for that. And it's a very interesting thing to do, because if you start using dialogues, then when the keyboard shows up, it's only going to resize the dialog window, and it's not going to resize the underlying window. So that's a lot of advantages. Also, so more windows means more composition, so it's harder work for the hardware. But it's also like when you're messing with that view hierarchy here, when it's in a separate window, the window that's behind it is not going to change. So rendering the window behind it is going to be super fast.
Okay, so the last one.
Okay,
the last one is about the scope singletons. When you exit the view, the scope singleton is gone, and you release the memory. Is there a suggested way to handle caching some fetched values from the internet, if you don't really want to drop all the values that you fetched between screens?
Okay. Yeah, there's no library or simple solution for that. Mostly, just build a cache and then inject a cache and just put the values in that. So if you want an in-memory cache, we have like, I think Jake made an LRU cache, if you know the size of your things. So just inject an LRU cache and just reuse that, and then you might want to save things on disk. I mean, you'll have to write that code, but we can do everything for you, come on. No, yeah, thank you, good questions.
Hello.
Hi.
So in more or less complex application, we have like a couple of screens and maybe some complex interactions between them. Is there some way in Flow or Mortar to like choreograph interaction between screens when you want to show one screen, hide other two, and kind of that?
So, I mean, again, I guess yes and no. The idea with Mortar and Flow, with Flow especially, is that you're showing one screen at a time in a flow. So, and Flow is a backstack management tool and a navigation management tool. So, there is no like easy way to say, oh, you need to update that and this and like show these two screens. The way we've done that is kind of creating screens that are going to hold information on what, like if you need to update two places, they're going to hold all the fact that they need to update these two places. But a flow is linear by nature, right? It's you go from this place to this place and you go back, and you don't really go into two different directions. So I think we just write custom code to do that, plainly and simply.
I have a question. When you have in Flow, when you have a single activity architecture, how you deal with intent filters and URIs when you have some URIs from network?
I mean, there's this. So yeah, how do we deal with intent filters, URIs in activities? So first of all, we don't do a lot of that. So that's not a problem we've really looked into. I would think so. If you get an intent filter. Well, you have a separate intent filter, you get like a new intent, it means you probably want to do something like going somewhere else. So the way I would deal with that is just get the flow object and say, go to this new screen now because there's a new intent. And maybe I would actually replace the backstack with an entirely new backstack, depending on what's going on. You can very easily do that. Or you might decide to show something in the UI, it's very specific to your use case. But by nature, Flow shouldn't prevent you to do that, I think. There's 1, 2, 3, 4, 5. We have 8 minutes.
Hi, Pierre. Thank you for a talk and again sharing for all those libraries. I think all of us use them a lot. I have a quite practical question regarding the Dagger version 2. Because you mentioned that you are using it on a real application. And we also does, I think. And I have a question, how do you guys handle and deal with the fact that Dagger is distributed under the snapshot version and it changes a lot in the repository, and sometimes Gradle just fetches new version and everything breaks up? Thanks.
So yeah, that's a very good question. So we use Dagger 2, but so basically the idea with Dagger 2 is still a snapshot version. It works perfectly. It's like super stable. Google, I think, uses it for Google search, and they had like a 30% performance improvement, I think. I don't remember the details. Anyway, so it's great, but it's not released because we're still arguing over the name of the methods and the name of the APIs, and like they want it to be like perfect, so that's why it's not fixed. So the way we've just handled that is we just checked out the repo and made a custom build. I actually made a custom build that has Dagger 1 and Dagger 2 in the same jar together. And then we just depend on that, and it never changes. So I actually noticed that some stuff break when we were updating Mortar and trying some new things with Mortar, and then everything was broken. And I realized, oh, cool, our app isn't broken because we're not depending on the snapshot version.
What's even more funny, maybe it's not the fact that Dagger itself is distributed under the snapshot version, but Dagger itself depends on the Google Auto Value library, which is, again, a snapshot version.
Yes.
So every time Google guys publish something, the Dagger also fetch that, and that's broke.
I mean, yeah, it's, they have a lot of work. They're fantastic guys. They're really smart, but they are handling so many libraries, and at the core, they work for the internal teams at Google, where they also have a lot of work. So open sourcing stuff is not easy. It's gonna get better, but in the meantime, just download the source, make a build, store it somewhere on your internal repo, and just use that. That's gonna solve your problems, and then you'll need to remember to update from time to time, obviously. But I know, it breaks. It's sad. Sorry. No more questions? Oh, well, and then we can get some food.
If we don't have any more questions, then thank you very much, Pierre.
Thank you.